Okay, students, now I want to talk to you about how to do non-cause and effect comparisons. In other words, relationships. So if so you want to say, is something influenced by something, or is something related to something? If we're just looking at two variables, we would typically use a simple linear regression, which is also called a Pearson. If we wanted to look at multiple variables, then we would do what is called a multiple regression analysis. So I'm going to open up, I'll share my screen here for you. And so here I have my JASP program, which I open up, it's going to look something like this. And if I have an Excel document, and suppose that I am curious, what is the relationship between somebody's body weight now and some other variables, okay? Like birth weight, calories consumed, fat grams, VO2 max. Well, let's just pretend that I didn't have this data yet. And I was just curious, is there a relationship between somebody's body weight when they're, let's say as adults, compared to what they were when they were born? Okay, so that's what we're going to look at. So I have my JASP. I'm going to open up, go to computer, JASP, and I have multiple regression example, but it's all right. It's going to look just like it did in Excel, okay? But if I pretend like I don't have these columns because I just had these ones in Excel at the time, it would only upload those two. So I want to do a regression because I want to know, is there a relationship between weight now as adults versus birth weight? And I come to relationship and I go linear regression, which again, Pearson would be the same thing. And in here, whoops, I'm going to go linear regression. There we go. And I go, what is my dependent variable? Well, it's body weight. And this would be the only other variable if I didn't have the other columns there. Click it there and bam, guess what I get? I get an R value right there. I get an R squared value. And then I also get this P value, if you will. So the relationship between body weight as adults versus body weights when they were born is 0.38. That would be considered pretty much a weak relationship. And when we look at it, it's not significant. But again, with relationship, when we're doing a simple linear regression or a Pearson, I don't like to look at the p-values because it's either strong, weak, moderate. I just like to know, is it positive? Is it negative? And how close to 1 is it? Okay, so that would be an example of just doing a simple linear regression or a Pearson test, okay? And I know it's confusing up here. There's this correlation thing. I don't like to use that because it wants you to enter data a little bit differently. And so I just use the linear, okay? So now let's go back and pretend like we went, that didn't really give us a whole lot of information. I'm assuming there's more than just birth weight. So we took all the same people we'd had birth weights for, and we said, how many calories do you consume a day? And we entered all of that in for each person. So here's the first person's information, second person's, third person's, okay? And we said, how many, and then we actually said, okay, in the calories you eat a day, how many of that is fat grams? And then we also did VO2 maxes on everyone. And we were like, okay, we want to know, does VO2 max actually influence their body weight? Okay, so then I would go back to my JASP and I would do file, open, computer. I find the file, it's going to upload just like this. And I can go back to regression, linear regression. And our dependent variable, in other words, what are we measuring, is body weight. And what are the things that we think influence it? Those are the covariates. So we go bloop, 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 bloop. And remember in the class I talked about there's different ways to do multiple regression. You can enter them in one at a time. You can have them all in and take one out. That's where this method comes about. You have a forwards multiple regression, backwards multiple regression, stepwise multiple regression. It doesn't matter which one you select because it's going to do the same thing, okay? All right, so if I just do this, like, I'm just going to go forward. Okay, there you go. Doesn't really matter, okay? What I get here is, I'm going to actually come back and do it like this. What I have here is this this H1. This is what we're looking at. And it tells me this is the R squared, because that's what we look at in multiple regressions, that 94% of body weight can be explained by these variables here. That's really high. Now, this ANOVA thing, really all I'm looking at is a p-value. That just tells me that this whole model significantly explains it. I could actually get rid of that if I wanted to. I could go model and get rid of the ANOVA if I wanted. I think it's under statistics actually, but I don't really care because this is what I care about. When we come down here, when it comes to body weight, what seem to be the significant contributors to body weight? And you go, well, birth weight doesn't have much to do with it. The p-value is 0.4. kcals consumed, wow, that one is really significant. Fat grams consumed, not really significant. And VO2 max consumed, wow, that's not really significant. So in other words, this whole model of all of these things significantly explains body weight, but really the only one that's a significant contributor is calories consumed, if that makes any sense. Okay, so what does this R versus R squared mean? And sorry, R squared versus adjusted R squared mean? Well, R squared is what is the R squared value of all of these variables. Adjusted R squared is what is the R squared of really only the ones that are meaningful to the model. So if I added everything in here, yeah, it's going to start to slowly explain more, but is it really worth it? And is it a significant contributor? So this one is when we're doing multiple regression analysis, we actually look at an adjusted R squared as opposed to just the R squared, because that it's doing some extra work for us. It's saying, okay, what are the important variables and what do they really give us? And what are the important variables? In this situation, it's just calories consumed. So if someone said, now again, this is fictional data, I just made it up, but based off of this, someone's going, what's the biggest, what influences my body weight? You would say, well, really, guess what the significant contributor is? How many calories you consume. Does it really make a difference whether it's fat? Well, according to this model, it doesn't. Well, what about my fitness level? Well, fitness level doesn't seem to influence body weight. It's mostly how many calories you consume. You go, well, that doesn't make sense. Well, what are some of the limitations to this thing? We don't have BMI. So would it make sense that the taller somebody is, the more they would weigh? Yeah, so there's other things. So that might be a weakness to this, but I'm just trying to explain what the data means and how to interpret it. And again, cool things with JASP is you can come in here and do some plots. If you don't understand what the plot means, I wouldn't mess with it, because at the end of the day, all we care about is this p-value associated with the multiple R squared adjusted, and is the whole model significant? All right, and I believe that is it.